Find a partial fractions decomposition for 2x plus 1 over x times x minus 1 times x plus 2. So somebody's done a little bit of work for us because the denominator here is already factored. So we can jump right into the creation of our constants. It was x minus 1, it was x plus 2, right? Yes. Always a good idea to make sure we get these things correct. So we'll say that must be equal. Here's our partial fractions, a over x, b over x minus 1, and we'll go c over x plus 2. Okay, fantastic. So now what do? Well, we multiply both sides by x times x minus 1 times x plus 2. And what will happen is you'll get 2x plus 1 over here on the left. Okay, now you'll have a over x times x minus 1, x plus 2, but those x's will cancel each other out. So instead, we could just simply write a x minus 1 times x plus 2. Similarly, when we multiply the b over x minus 1 by this, the x minus 1's cancel out. Okay. And for c, we get a similar story. So there we go. Now what can we do? We want to solve for a, b, and c. Now I notice that both b and c have an x here. So if I were to do something like, and it's always a good idea to show your work, okay, if you're showing this off to someone or explaining something, tell us what, tell me what value of x you're going to use. But if we use x equals 0, we'll get 2 times 0 plus 1. We'll get 1 over here on the left-hand side. Must be equal to a, 0 minus 1, 0 plus 2. But then it's going to be b times 0. And then c times 0. So we can ignore those. Okay. So 1 is a times negative 1 times 2. And so negative 2a is 1, or negative 1/2 is equal to a. We can do the same sort of thing for the other constants. Notice that a and c both have an x minus 1. So if we were to let x equal 1, 2x plus 1 gives us a 3 over here. It'll be a times 0, so no one cares. A c times 0, this is why we chose 1. So these x minus 1's go to 0. And then it's b times 1 times 1 plus 2. This is the one we actually need to write out. So 3 must be 3 times b. And from there, I see that b must be 1. Okay, one more to go. Is there something special that could let us figure out what c is? Well, both b and a have x plus 2's. What makes that equal to 0? Negative 2. So if we plug in x is negative 2, we get negative 4 plus 1, so that's negative 3. And it'll be a times, there's some stuff, but there's going to be negative 2 plus 2, so we'll get a 0 there. B will have 0, that's why we chose negative 2. Or sorry, C, no, which one? We're trying to find B, yeah. And so then it'll be C times, so x is negative 2, and then negative 2 minus 1 will be negative 3. So negative 3 is 6c, so c is negative 1/2. Okay, so that should do it. Our partial fraction decomposition, we know all the constants. So negative 1/2 for a, and b was 1, and c we just found out is negative 1/2. And there we go.